Welcome to my digital class. Today in this class we are going to understand those concepts which are very much required to understand the trigonometry. So today we are not going to start trigonometry, but we are going to learn in this class those concepts which makes our trigonometry to understand easily. So what are these type of topics called as? I have given a name. It is pre-trigonometry concept. In order to understand trigonometry nicely, so these concept we must know. Otherwise, what happens? You will understand the trigonometry if you start directly trigonometry, but while solving the problems, you may get a problem. You may stuck over there. So the if you are having this mathematical basic knowledge which I am going to give in this video, then the trigonometry easily can go into the heads and we can understand it comfortably. If we understand the concept, the confidence will come. As the confidence develop, then we love maths and we play with maths. We get more marks in maths and it is our mental ability improvement. So let us go directly to learn the concept. So here I have written some headings there. Simplification of rationals and irrational numbers is very much needed, and we must understand the terminology of right angle triangle and also the Pythagoras theorem. Let us take some of the questions for rationals and irrationals and get a little concept there itself. The practice questions are there. Please practice them and proceed. If somebody feels that no, these are very easy concept, I am very much confident in it, then you please fast forward this. Play with the speed of 1.5, 1.75 or 2. Then go to the next module. Very nice. Let us go to the questions now. Take the questions. Come on. There are the questions for the practice. Number one, simplification of rationals. 3 rationals here, all are of same kind. Let us take one question to solve it. So let us take question number 5. Minus 9 by 10 plus 22 by 15 plus of 13 by minus 20. So we have taken a question. Here plus times minus is actually plus times minus, and in the rational numbers, the standard form is the minus number we don't keep in the denominator, the minus sign we keep in the numerator. Let us transfer that to the numerator and then multiply with this plus sign. Then you will get exactly minus 9 by 10 plus 22 by 15 minus 13 by 20. Okay, so actually what happens here, the denominators are not same, so we cannot add and subtract the rational numbers or fractions. So what we need to do, let us take LCM and make each and every denominator same. When the denominators are not same, we have to make the denominator same. So we are going to make the denominator same right now. So what we must do, we must take the LCM. So here comes the LCM 10, 15, 20. So we got the LCM as 60. Then we have to make each and every denominator as 60. So we are increasing each rational number to its equivalent rational number by multiplying and dividing some number. If a rational number you are having and you need to multiply and divide by some number, the value doesn't change. For example, you are having 5 by 3, you are multiplying by 2, dividing by 2, then this value doesn't change. Rather, the number in the numerator and denominator changes, whether it is increasing or decreasing. But if you multiply and divide by the same number, then the actual value doesn't change, it just is equivalent. So here each fraction, this fraction and this have been multiplied by one suitable number such a way that the denominators are becoming exactly 60. So each denominator became 60 right now. Okay, then we take the LCM, every denominator we got a 60 degree, then sorry 60 number. Then what we will do is multiply the numerators and denominator. We got this step. Then take a whole denominator 60 and collectively write all the numerators. According to integer operation, all negatives will be added. Add them. Minus 54 minus 39, you'll get exactly minus 93. Then this is plus 88, so one negative number, positive number, you have to subtract. Greater number sign you will put there, so you got minus 5 by 60. And if you are reducing, cancelling it by 5, I will get this one. This is the most simplified answer for this one. So in this way, you please take remaining 5 questions in practice. I hope that you are taking pen and paper, sitting with pen paper to see some practice questions also. So please take those practice questions and solve it. Pause this video here itself, do this and proceed. Well, you have I hope that you have practiced those questions. Now let us take some more questions on irrational numbers and some questions on complex fractions. What do you mean by complex fractions? A fraction is nothing but a rational number is made with the help of numerator and denominator. Numerator is again a fraction type, denominator is again the fraction type. So let us see the complex fractions also. Here comes some of the questions on irrational numbers, how to simplify to bring it to standard format. Here number 1 question, number 2, number 3 and number 4, they are a bit easy because in the denominator they have given root 9, here root 16, root 4. Moreover, this root, they are perfect squares, so root 9 will be simplified to get 3 here. Root 9 is 3 times 4 is 12, and you can just give the denominator to separate numerator and get the answer. So they are a bit easy. I want to simplify one of the question from 5 to 8. So let us, okay, I'll take question number 8 so that we'll comfortably understand the topic now. Simplify is question, and question number 8 I am taking for your sake. Question number 8 is coming with my pen now. Solution for question number 8. What is the actual topic for this type of question is 5 divided by 2 root 3 minus root 2. What I have to do here, I must simplify. Why I must simplify? Because the denominators are irrational numbers, and in our mathematics we don't keep our irrational numbers in the denominator. It is not in the standard format. So I have to simplify, means I have to rationalize the denominator here. And how to do? I have to multiply and divide by the conjugate of the denominator. What do you mean by conjugate? For example, I'm having 1 minus root 3. Its conjugate will be 1 plus root 3. If I'm having root 2 plus root 3, and its conjugate will be root 2 minus root 3. Just the two irrational numbers or integer irrational number, the middle sign we have to change and multiply and divide. So I'll write a heading, rationalizing the denominator. Okay, so 5 divided by 2 root 3 minus root 2 times, sorry, it's okay, so 2 root 3 plus root 2 divided by 2 root 3 plus root 2. Same numerator, denominator. Why? And after multiplying, dividing, you should not cancel. We, by thinking something, we multiply and divide, and if you cancel, again we'll reach to the previous step only. Don't do that. So if we multiply the numerators, I get like this. Still simplification, we can do the next step. Here the denominators are, whenever we are taking conjugate and multiplying, dividing, what happens, they come under the formula like this: a plus b times a minus b, a square minus b square. So you can use this concept here: a minus b, a plus b. So it will become a square minus b square. Next step, let us go to the next step now. Okay, so let us go to the next step. Then what is the next step telling us to do? So multiply the numerators. 5 times 10 root 3 plus 5 times root 2 is 5 root 2 divided by a square. It is actually made with the help of two numbers. So 2 square is 4, root 3 square is 3, in between the multiplication 12 it is, and root 2 square is only 2. So it's 10 root 3 plus 5 root 2 divided by 12 minus 2 is 10. In this way, we have to rationalize the denominator. Okay, these are the steps for rationalizing. So take some practice questions to it. Let us go to fraction of a fraction type, then fraction of a fraction irrational, then one of the topic to grab the concept, basic concepts will be clear, then we can go to the next topic. Let us go to fraction of a fraction now. Here we have taken some 4 questions which are of a fraction type, that are complex rational numbers, or you can take complex fractions. And here the numerator itself is some combination of fractions, and denominator of a big rational number fraction is again a fraction of a fraction. How to solve this type of questions? Because this type of simplification part is continuously going to come in your trigonometry. I have collected for your sake. It is very nice way we are going to grab this chapter now. Yes. Let us take a question number 1, and the rest 3 questions will be your questions. Solution for question number 1 now. Okay, let us go to question number 1. Okay, I'll take a question number 2 itself. Let us take question number 2. Take a question number 2 now, because I'm seeing question number 2 in front of me. We are all same type, but numbers are different. You practice them. Okay, now when I am having numerator and denominator of fractions, so I have to simplify the numerator as separate simplification, and denominator also the same. So I got LCM of 5, 1 and 2 as 10. Directly I want 10. In the basics here, as we have done this problem in the very simplified and easy go, directly from here to here we can reach, and these steps we can do in our mind. How? Actually, I was having here 9. 9 is multiplied by 6 to get 54. Why we multiplied? Because this 10 is to be made 60. In order to make 60, I have to multiply with 6. So 10 times 6, so it is 54. In that way, directly from here we are reaching here. So let us go. I have taken the LCM 10. This 5 became 10. So I have multiplied it. I multiplied 2. So 2, the numerator should be multiplied by 2. I got 4. Then 1, the denominator became 10 by multiplying by 10. So I have to multiply this numerator with 10. Okay. This 2 became 10 by multiplying by 5. So I should multiply 3 by 5. I got a 15. Similarly, in the denominator itself, the LCM is going to become 20. And I have to multiply 1 here with 20. and this numerator 1 I have to multiply by 4, because here the denominator is 5 times 4. Okay, then I have to multiply this 4 by this 3 by 5 times 3 15. In this way we proceed. Let us go for the simplification. What is going to become in the numerator? 4 minus 10 minus 15, exactly the two negatives, minus 25 plus minus 21, and denominator is 10. I want to bring this denominator fraction to the numerator by reciprocally. So it will become like this, 20 divided by this 20 will come up, and this numerator I simplified. 20 plus 15 is 35, minus 4 is 31, and we can cancel it, write some simplification, this numerator and denominator. I got it 2, multiply. Is there any cancellation further? No. So 21 times 2 is minus 42 divided by 31 is answer. In this way we have done a problem on a fraction of a fraction type. So I request you to take the practice question. More 3 questions are waiting. You please take your pen and paper, practice and proceed. Come on. Here you can pause the video, do your work and proceed. Okay, let's take some questions now on complex irrationals, that is fraction of a fraction type with irrational numbers. Let us take some questions. I'm going to use pen and write some questions for you. Come on. Here also I take 4 questions, 1 for myself to solve, the other 3 will be your practice questions. Be ready with your pen and paper. Okay, so here I have given questions to you, 4 questions of similar fashion. Let us take one question and solve this question. Let us take question number 2. Solution for question number 2. I'm copying the question now. 1 minus 1 by root 2 minus root 3 by 2 divided by 1 plus root 3 by 2 minus 3 by 4. So when we are having a fraction of a fraction, numerator we have to simplify separately, denominator separately, but they will collectively look alike. So in the this is our basic denominator line. The numerator's denominator are 2 root 2. So LCM is going to be 2 root 2. I have to multiply 1 by 2 root 2 because the denominator was 1, exactly it became 2 root 2, so I have to multiply, and this numerator should be multiplied with only 2. So 2 times 1 is 2. Root 3 is already here and I got it 2 in the denominator, extra root 2. So root 3 should be multiplied by root 2. Root and root, they are the same powers, they can be multiplied inside. Power I said because root is having power 1 by 2. Here also root 2 is having power. The same powers inside you can multiply. Square root can be multiplied inside. But square root and cube root cannot be multiplied. So now, can be multiplied. They will be sit aside like this. But inside the roots you cannot multiply. Root 3 times root 2 is root 6. Similarly, denominator are 2 4, so LCM I will get as 4. And here the denominator was 1, exactly it became 4. Now it should be multiplied with 4 plus root 3 here, and I got it 2. 2 times 2 will be 4, so I should be multiplied with 2. 2 root 3 minus here actually 4, and the denominator is also 4. No need to multiply anything. So we got a simplification part here, this much. Let us proceed. This is the actual denominator and bigger one. Then 2 root 2 minus 2 minus root 6. There are no like terms, no simplification. Exactly keep it as the same. I want to bring this denominator to the numerator, reciprocal, and bring it to the numerator side. So is there any like terms? Yes, 4 and minus 3 can be simplified. Minus 4 minus 3 is 1 plus 2 root 3. Yeah, still simplification is needed. We can simplify. So what is the simplification now? This 4 can be cancelled with this 2. I'll be left out with only 2 in the numerator here. This 2 can be multiplied with all the numerator terms, so it will become 4 root 2 minus 4 minus 2 root 6 denominator. This root 2 should be multiplied with this another product. Root 2 times 1 is root 2 plus root 2 times root 3, 2 root 6 it exactly becomes. Now we reached to rationalizing part. This is the simplification completes, but we don't stop here because the denominator is having irrational number. So we don't keep denominators irrational number. We have to rationalize. Let us go to rationalize the denominator. Okay, I'm going a little bit here now. 4 root 2 minus 4 minus 2 root 6 is multiplied with conjugate. Just before we have seen conjugate to be multiplied. Why? Because the denominator exactly comes in the formula a plus b times a minus b, and it will become a square minus b square, and the squares makes the under root to be cancelled and we get a rational denominator. Okay, so numerator we can keep as it is, but we'll simplify that also. 4 root 2 times root 2 exactly. 4 root 2 times root 2. So root 2 times root 2 is 2. 2 times 4 is 8. I got an 8 here. 4 root 2 times 2 root 6 exactly. It is going to become 4 times 2, 8. Root 2 times root 6 is root 12. And root 12 is not in the standard format because root 12 can be written as 2 times 2 times 3. 1, 2 can be taken outside. So it will become 8 times 2 times 3. It will become 24 root 3. So we'll write 24 root 3 in that place. This is all rough work. 24 root 3. We multiply this with 2 root 6. You got 24 root 3. Now 4 should be multiplied with both this minus 4 root 2, and 4 is multiplied with minus 2 root 6, so exactly it will become minus 8 root 6. This 2 root 6 should be multiplied with again these 2. 2 root 6 times root 2. 2 root 6 times root 2. Exactly it is becoming 2 root 12, and just now 12 is like this. It will become 2 times 2 times 3, 4 root 3 it is actually. What it is? 4 root 3. So we will be using 4 root 3 right here now. So 2 root 6 multiplied by root 2 is minus 4 root 3. 2 root 6 multiplied by 2 root 6, minus times minus is plus. 2 times 2 is 4. Root 6 times root 6 is 6. 6 4 is 24. We get 24. Exactly in the denominator is going to be a plus b into a minus b, a square minus b square. Root 2 square 2. 2 root 6 square exactly. 2 square is 4. Root 6 square is 6. It's 24. 24. And is there any like terms in the numerator to be simplified? We'll see. Minus 22 in the denominator. This is the integer. This is an integer. 8 plus 24 is going to be 32. Root 3 here. Again a root 3. Minus 24 minus 4 root 3. Exactly 28 root 3. We got a 4 root 2. Only one more. 4 root 2 and 8 root 6. Complete. Is there any more simplification? No. Yes. We just see the denominator is minus. We should not keep the minus sign in the denominator, so we'll keep this minus to the, will give this minus to the numerator. How should, just you take this minus and multiply all the numerator terms. So it will become minus 32 plus 28 root 3 plus 4 root 2 plus 8 root 6. In this way, my complex irrational numbers simplification part is there, and this is very necessary in the chapter trigonometry. Well, so take some other three questions other than this problem as a practice question. Pause here, start solving that problems. So very nice. Let's proceed with other, but you after the solution of your practice questions. Okay, now let's go to understand the terminology of the triangles, how the triangles are there, what are the names of the sides, how many different types of triangles are there, and what are the relationship between sides and angles. Let us understand this concept, then proceed with Pythagoras theorem. That ends with our concepts which are required to understand the trigonometry. Let us take a triangle and proceed. Come on. Here comes a triangle, and I have taken a right angle triangle for our kind consideration. Why I have taken? Because total trigonometry concept we learn on in the right angle triangle only. Why we use right angle triangle only? Because in our basics, that is 10th class level, is the basic and starting level of our trigonometry. That is why we go with right angle triangle. But the triangles, okay, then right angle triangle, we are considering only right angle triangle because the total 10th class textbook, whether it is a chapter trigonometry, application of trigonometry, both they all deal with right angle triangle only. So right angle triangle is to be considered very nicely. We'll understand the concept of right angle triangle. So right angle triangle in front of you, a triangle name, we have kept a right angle triangle ABC. Here is 90 degrees, so the symbol will come. And in the basic from the 6th class or 7th class, when we started studying triangles, a right angle triangle also we studied there, and then the side which is opposite to 90 degrees called as hypotenuse, and these two sides are called as perpendicular sides. Among them, one is called as base and another is perpendicular altitude. Or perpendicular. See here, these were the concept we have used in the previous classes, but the terminology which we are going to use here is little bit different. We want to bring a relationship between the angles of the right angle triangle and the sides. How to name the side with respect to angle, that is important in the trigonometry. So we are learning how the trigonometric side, right angle triangle sides will be related with angle. This is 90 degree. With respect to 90 degree, one relation, this is hypotenuse, and these two sides are perpendicular sides. Okay, with respect to this angle, so what is this angle? Here we don't get a name. This is angle C. With respect to angle C, when we are talking about, then this side is adjacent side of the angle C. Then what will be this side with respect to this angle C? So it will be opposite side of angle C. Okay, let's go to angle A and get a relation. Okay, so angle A is here. With respect to angle AB, the side is adjacent side. With respect to angle A, the BC side, this side is opposite side of angle A. Okay, let us write these things. we are going a little bit slow because everything we want to understand. Don't be panic. We are taking a triangle now. Oh, go triangle, please come to my. Okay, here come a right angle triangle now. Yes. Again, the names we are taking. Let us take the triangle name P, Q, R, and this is 90-degree. Tell me what will be the names of the sides with respect to angle R. So with respect to angle R we are talking about, so this is adjacent side of R, and I can tell here opposite side of R. Okay, with respect to P, if we are talking about, then this is opposite side of P. See here, this is opposite, and this will be adjacent side of P. So confusion, each perpendicular side sometimes is called as adjacent, sometimes is called as opposite. So adjacent to adjacent means adjacent to what? Adjacent for R, opposite to P. Similarly, if any side, it is opposite of what takes what angle. In this way the names are written. Hypotenuse is hypotenuse everywhere, whether what respect to you're talking, whether R or P, hypotenuse is same. Now I think it's clear what are the sides names with respect to the angles. When we are talking about any side, we have to relate it with certain angle. Then with respect to that angle, whether it is adjacent or opposite, we need to understand. Let's proceed. Well, it's fine. Now we have understood the terminology of right angle triangle. So for example, R and P, instead of R and P, somewhere in the problems a variable letter is used, which is called as theta. It is used to represent any acute angle. So with respect to theta, if we are talking about, so theta can be sometimes here, sometimes here. So where the theta is according to there, we have to decide. So here with respect to theta, the opposite side is PQ, adjacent side is QR, hypotenuse is PR. And if we are writing theta somewhere else in this triangle, for example here, again with respect to theta, means in one triangle two places theta will not come, in one place only. So this is the concept to understand. Let's go to some problems of Pythagoras theorem. Let's go. Here I have drawn some of the right angle triangles. Among them, sometimes I have kept a right angle in this fashion. Again change here, right angle is completely different. Here's the right angle. I want to apply Pythagoras theorem here. When we apply Pythagoras theorem, when we are having any two sides, we want to find the third side. Any two sides of the right angle triangle, the third side can be found with the help of Pythagoras theorem. Let us see here one example. In this example, we got, for example, here 5 and here is 4. We don't know BC, how to find. So in triangle ABC, right angle at B. So by Pythagoras theorem, according to the Pythagoras theorem definition, hypotenuse square is equal to the sum of the squares of other two sides. Then it should be AC square plus, I'm sorry, I got a mistake, no problem. Now see here, AC square is equal to, because hypotenuse is here, hypotenuse square is equal to AB square plus BC square. This is the basic definition. Now Substitute these values. 5 square is equal to AB 4 square plus BC, we don't know BC square. So now I want to transpose this. 5 square minus 4 square is BC square under root. Let us take under root the next case. Next step, 25 minus 16 is equal to BC square. Then it is 9 is equal to BC square under root 9 is your BC is your 3. So you got the values. Now we got the BC value from our basic definition. This definition can be manipulated by transposing the unknown, keeping unknown on the left hand side. If I want directly BC square to be left hand side, then hypotenuse square minus 1 of the given square. This is also the Pythagoras theorem, where just I have transposed the unknown side to the left side. If we want directly this step, directly we reach here. So BC square, we want this value. AC is 5 square, AB is 4 square, and 25 minus 16 is going to be 9. BC is square and BC is under root 9 to be 3. In this fashion, if hypotenuse is to be found, let hypotenuse be on the left hand side. If any one of the perpendicular side is to be found, keep that unknown side on the left hand side. But how to decide what will be coming in the right hand side? RHS will be in this fashion. If you are finding hypotenuse, sum of the squares of other two sides. If you find any of the perpendicular side, the hypotenuse square minus any one given side square. In that way, the definition is going to be changing. Okay, so you will learn here Pythagoras theorem also. So take some of the questions for practice and find unknown side with the help of Pythagoras theorem. Here we have taken some of the right angle triangles and two sides are given, third side to be found. With the help of Pythagoras theorem, please find these three problems, 3 right angle triangles, unknown side. Come on, pause this video, do these practice questions, then proceed. After completion of these problems, we have learned number 1, simplification part of rationals and irrationals. Moreover, we have seen complex rationals also. Number 2, terminology of right angle triangle. Number 3, Pythagoras theorem. Hope this knowledge will be useful to learn and understand trigonometry easily. Thank you. Let's go to the chapter trigonometry. Let's go. Thank you. Welcome to my next class of trigonometry. In the first class, we gather a lot of information about pre-trigonometry, those concepts which are helpful to understand trigonometry easily, and collectively the simplification of trigonometric problems will get easier. So we grab the basic knowledge there. Now just we are entering into the chapter trigonometry. Yes, trigonometry. What do you mean by trigonometry? It's very easy to, it is a branch of mathematics which deals the complete calculations of right angle triangle. Yes. So here, to understand what is right angle triangle, what are the sides, everything, and what different topics we are going to understand in trigonometry, line by line we go. So the first number 1 topic of trigonometry chapter is trigonometric ratios. So what do you mean by trigonometric ratio? According to the simple definition of the trigonometric ratios, trigonometry totally deals with the right angle triangle. So trigonometric ratios must be the ratios of the sides of the right angle triangle. Yeah. So what are the names of the sides of the right angle triangle? So the names of the right angle triangle are related with the respect to angles. So we shall make certain ratios now. Are you ready to make certain ratios of the sides of the right angle triangle? Let us make. Names of the sides are with respect to angles. So names of the sides we are using with respect to angles and making certain ratios. So let us make certain ratios now. Number one ratio can be, for example, this is the angle. If I name this angle as theta, if I don't name here theta, then automatically it can be as C, angle C. So with respect to theta I am talking about, or with respect to C I am talking about. Then the one ratio can be like this: opposite side of theta by hypotenuse. One ratio there can be like this, and there can be one ratio adjacent side of theta by hypotenuse. Adjacent side of theta by hypotenuse. There can be one ratio opposite side by adjacent side. Yes, so there can be ratio opposite side of theta by adjacent side of theta. Yeah. So there can be a ratio just reciprocal to this. It can be like this: hypotenuse divided by opposite side of theta. And there can be a just reciprocal of hypotenuse divided by adjacent side of theta. And there can be one more ratio just reciprocal of this. It can be adjacent side of theta by opposite side of theta. There cannot be a seventh ratio with respect to three sides. If you are taking three sides with respect to any angle, there cannot be more ratios than 6. So we get 6 ratios. So if graphically, if we see, just this side is called as opposite side of theta, this side is called as adjacent side of theta, and this is hypotenuse. So opposite side of theta by hypotenuse, adjacent side of theta by hypotenuse, opposite side of theta by adjacent side of theta, and reciprocal. These are the trigonometric ratios. That's all. What are trigonometric ratios? The ratios of the sides of the right angle triangle. So each ratio is given as respective name. For example, the first ratio, opposite side of theta by hypotenuse, is named as sine theta. So you may be wondering, or you may have heard about different trigonometric ratios names: sine, cos, cosec, secant, cot, tan, cot. And these trigonometric ratios you may have thought that new names are coming, whether this chapter is very hard and how to understand sine, cos, cosec, these are different things. No baby, it's very easy. What are those? These are the ratios, and each ratio have been given a name. This ratio opposite by hypotenuse is given a name as sine, and y theta here with respect to theta we are deciding opposite and hypotenuse. So whether it is theta or here can be theta, just according to the theta we have to decide opposite and adjacent. Okay, the other name adjacent side of theta by hypotenuse is called as a name cos theta. Wow, it's great. And this opposite side of theta by adjacent side of theta is named as a tan theta. Okay, well, is it great? Easy. Let us take this name is just reciprocal of this. If you see opposite side of theta by hypotenuse, exactly opposite of this, reciprocal. So this is also a trigonometric ratio. Let us name it. It is a cosecant theta. With this formula also we can just learn sine and cosec, and they are reciprocal to each other. Moreover, let us learn about this ratio and call a name. This is I'm sorry, I'll take a eraser and erase it. Take a pen and secant theta. Wow, So easy. And last ratio is named as adjacent side of theta by opposite side, reciprocal of tan, named as cot theta. Over. So 6 trigonometric ratios have been given, 6 names: trigonometric ratios: sine, cos, tan, cosecant, secant, cot. Wow, very easy to learn. Trigonometric ratios. What are the trigonometric ratios? Once again, recall they are the ratios of the sides of the right angle triangle. So each ratio have been given a special name. That's all. Trigonometric ratios. Let us take some of the different right angle triangle and decide what could be sine, cosec, secant, cot, and tan. Let us try this. Yes, let us take a right angle triangle in this fashion. Now I have changed the structure of a right angle triangle. A triangle A. I'm writing here C. I'm writing here D. For your kind information, where C here is a 90 degree. Practice, make different right angle triangles. Practice these trigonometric ratios. And orally also, you should know what is sine. Sine should be opposite by hypotenuse. What is sine theta? It should be opposite side of theta by hypotenuse. What is cos? Ratio tells the adjacent by hypotenuse. What is cos theta? It should be adjacent side of theta by hypotenuse. What is tan? Tan is opposite by adjacent. What is tan theta? It should be opposite side of theta by adjacent side of theta. In cosecant theta, it should be a hypotenuse by opposite side of theta. What should be a secant theta? Hypotenuse divided by adjacent side of theta. And what should be a cot theta? It should be adjacent side of theta by opposite side of theta. So in this way, let us see now what should be where I am keeping a theta. I am keeping my theta here in this place. I want what should be a sine theta. Decide me what will be a sine theta now. Sine will be opposite side of theta by hypotenuse. So theta is here. With respect to this will be my opposite and this will be my hypotenuse. So don't fix opposite and hypotenuse and adjacent in any right angle triangle unless and until you are not told about with respect to what angle you have to speak. Never tell what is adjacent, what is opposite. So with respect to theta, theta is my here, then this side will be opposite and this side will be opposite, hypotenuse, and this side will be adjacent side. So sine theta will be according to the definition completely opposite side of theta by hypotenuse. Directly I'm taking from write the definition: opposite side of theta by hypotenuse. Then opposite side of theta by dc by AD. Yes. Similarly, it can tell me cos theta will be adjacent side by hypotenuse. So it should be according to the definition AC by AD. AC by AD. Similarly, please by yourself give me the answers about tan theta and cot theta, cosecant theta and secant theta. What will be the ratios? So take different right angle triangles. I practice and remember orally also what is sine theta, cos, cosecant, secant, cot, and tan. Sine opposite by hypotenuse, cos adjacent by hypotenuse, tan opposite by adjacent, and cosecant hypotenuse by opposite. What is secant? Hypotenuse by adjacent. And what is cot? Adjacent by opposite. So let us in the right angle triangle, one more right angle triangle I will take for your sake, and let us graphically represent it. We should never forget it now. So what I want here, I want my pen to be active now. This is my pen, PQR. With respect to theta we are talking about, this will be opposite and this will be hypotenuse. The arrows tell me the opposite by hypotenuse and it will be sine theta. This arrow tells me that this is adjacent by hypotenuse and it should be a cos theta. Okay, This arrow tells me that it is opposite by adjacent. It should be my tan theta. Okay, just if you are changing the orientation, hypotenuse by opposite, it will become cosecant theta, and the orientation, if you change hypotenuse by, it will become secant theta. If you change the orientation, so adjacent by opposite, exactly right, like this, then exactly it will be cot theta. Over, you please practice orientation, draw the diagrams, and remember it should be like this. And if you are not drawing the diagram and not making so many times, if you remember what is sine opposite by hypotenuse, what is cos adjacent by hypotenuse, what is tan opposite by adjacent, and the other three are reciprocal of this, that's it. No need to go elsewhere. Now let us take a activity and come to a little certain derivation part, observation part. So what we have done here, we have drawn different same right angle triangles where every right angle triangle is having same angles, because here 90, this common, so all similar right angle triangles. For example, if I fix this right angle triangle, this angle as 30 degree, then what happens if you make so many right angle triangles in this fashion and measure this one of the side? How many infinite number of right angle triangles of this kind you can make? You measure that particular right angle triangle opposite side and measure hypotenuse side. Then with respect to 30, we are talking about, so I can write sine 30. You take opposite of sine opposite of 30 degree, opposite of 30 degree, opposite of 30 degree divided by hypotenuse of triangle ABC. Then what happens, you measure this and this is activity type, take, and if you are doing the calculation, the answer should be approximately 1/2, that is 0.5. Similarly, if you are taking another triangle DEC, again measuring DE value and measuring DC value, divide DE by DC, exactly you will get 0.5. If you are taking a triangle PQ and C, measuring PQ and measuring PC, again you are dividing PQ divided by PC value, exactly again it should be 0.5. What does this mean? Whenever we are performing this opposite by hypotenuse in any right angle triangle, any, but the angle is 30, so in a right angle triangle sine 30, in this right angle triangle sine 30, in this right angle triangle sine 30, everywhere you will get 0.5, 0.5, 0.5. It means that trigonometric ratio does not change if the lengths of the sides are changing. Accordingly, you have to make the angle constant and make different right angle triangles and do this activity. You will come to the conclusion that as we are changing the lengths of the right angle triangle but the angle remains same, the trigonometric ratio values does not change. So here comes the definition for this. The value of trigonometric ratios of an angle do not vary with the length of the side of a triangle if the angle remains the same. So you can remember this, it can come into 1 mark answer. Okay, now let us learn how and what are different types of questions can be asked in the trigonometric ratio exercise. So what are the different types of questions can be asked? So I have collected different questions which may be asked on, which are being asked in the trigonometric ratios. The number 1 type question is, one of the trigonometric ratio will be given and he will ask us to find all the trigonometric ratios. Number 1 type questions. And if we see, this is one of the model where one trigonometric ratio will be given and he may ask us to find all other trigonometric ratios. One more, he will give us the two sides of right angle triangle and he may ask us all the different trigonometric ratio values, and that can be the question of this type where we got two sides are given and he may ask us to find all the trigonometric ratios. And here one trigonometric ratio in this way he has given and he may ask us to find all the trigonometric ratios. So now I can tell you these both the questions are of same kind. How? I'll show you. Please concentrate that given tan A is 4 by 3, find other trigonometric ratios of the angle A. So first of all, let us draw a right angle triangle to solve this type of questions. Solution for this type of questions, a right angle triangle where I want my A to be here. So tan A tells us that everywhere we have to understand the sides with respect to A. Here is my A, this side will be an adjacent side of A, this side will be opposite side, and this will be hypotenuse. I have to decide according to this given letter. So tan A is equal to 4 by 3. Tan A is equal to 4 by 3. In just the previous one activity, we have understood that as the sides of a right angle triangle increases but the angle remains same, the trigonometric ratio does not change. Means what? As the lengths we change accordingly, means we have proportionality changing the sides but angles remain same. So that makes me here 4 by 3 can be 4k by 3k. Any triangle having the sides in the ratio 4 by 3. It is just doesn't, the 4 by 3 does not tell me that it is 4 centimeter and the other side is 3 centimeter. It tells the ratio 4:3. It can be, and the 4 by 3 tells me that it can be 4 times 1 times 1. It is actual 4 by 3 and it can be like this. It is valid and good for this sides also. If I am multiplying with this 7 and 7, 28 and 21, for it is valid for this question also. That is why K we have introduced that this trigonometric ratio, it is in the simplest format where the sides of the right angle triangle can be any of this format. Okay, so now let us take we have taken a angle here. Tan A is nothing but opposite side of A by adjacent side of A. So opposite we have written here, opposite. This should be 4k and adjacent, it should be 3k. Okay. Just I have said why this k came here, because in this previous question here we have seen that trigonometric ratio for different sides but the angle to be 30 have not changed. Practically you have tried these, then that is why whenever the trigonometric ratio tan A is 4 by 3 he is giving, it could be exactly 4 by 3 where 4 represent 4 centimeter, 3 represent 3 centimeter. It is not like that. It is a ratio, so it can be like this, 4 times 1, any triangle it could be. That is why k is introduced to tell to make it clear that it is not exactly 4 centimeter and 3 centimeter. Okay, tan A is 4k by 3k, opposite side of A by adjacent side of A. By using this we have to find the unknown side. Unknown side can be bought with the help of Pythagoras theorem. We have to apply Pythagoras theorem. Now in triangle ABC, by Pythagoras theorem, what is going to happen? AC square is equal to AC square is equal to AB square plus BC square, as in this right angle triangle. AC square is equal to AB square plus BC square. We can write 3k square plus is equal to 4k square. 3k whole square plus 4k whole square. AC square. 9k square plus 16k square. And it can be 9k square plus 16k square is 25k square. If I transpose this square to the other side, will become under root, and under root 25 is 5, under root k square is k. I got a 5k. AC value is 5k. I got a 5k. Now the question is to find all other trigonometric ratios. So what can be all other trigonometric ratios? What can be all other trigonometric ratios? What can be all other trigonometric ratios? Here it can be sine now. So what can be the sine now? Sine. Sine A is opposite side of A by hypotenuse. So can you tell me what can be sine A? Opposite side of A by hypotenuse. So it should be BC by AC is 4k by 5k. If you cancel k, answer is 4 by 5. So in this way you please find cos A value and got it. Tan A was given, sin cos. You please bring cos, then cosecant A value, secant A value, and cot A value. Cot A value. Okay, so please do it. Find this. In this way you will get some of the questions. Let us try some other type questions now. A model question is brought to you from the textbook. Consider a triangle ACB, right angle at C. Then AB is 29, BC is 21, angle ABC is theta. Let us draw the right angle triangle here. I am taking a right angle triangle for your sake. Let us take a right angle triangle, and the triangle is telling me that ACB right angle at C, so it should be ACB right angle triangle, right angle at C, and ABC is theta, so here is theta, and he want AB is 29 and BC is 21. AC we don't know, so we have to find a Pythagoras theorem and find AC value in right angle triangle ABC by Pythagoras theorem. And we learned Pythagoras theorem in this fashion also, that hypotenuse is to be bought, then square of this and square of the other two sides will be sum of the squares of other two sides, and if one of the perpendicular side is to be found, then the difference of the squares of other two sides, and the first will be hypotenuse. So AC square is not hypotenuse, that is why AB square minus BC square. AC is, we don't know AC. AB is 29 square minus BC is 21 square. Okay. 29 times 29 is how much? 841. 841 minus 21 square is 441. AC square can be now 400, and AC under root 400 to be 20 is your answer. And I got a 20 here, or otherwise as the previous case, everywhere k is introduced, then you can get k also here. Okay, then we need to find cos square theta plus sin square theta. Now cos square theta plus sin square theta, that is, can you write the cos ratio from the triangle? Theta is here, Adjacent is this side, opposite is this side, hypotenuse is cos. Adjacent by hypotenuse 21 by 29. And sine is opposite by hypotenuse. Opposite is here, hypotenuse here, 20 by 29. 20 by 29. Yeah, you can simplify it to get the answer. Now 441 by 841 plus 400 by 841, exactly 841 by 841. The answer is 1. And in the similar fashion, take the trigonometric ratio values and find cos square theta minus sin square theta value. Also, you can do this by yourself. Let us take exercise problems of our ncert book. For exercise of first exercise of trigonometry chapter. Let us go to exercise now. How many problems with this knowledge we can do, and that will be a practice sessions for you. You can do this problem as we have done one example problem of this kind. You can do this problem because two other sides are given, third side can be found with the help of Pythagoras theorem, and you can do this problem. And here again, a 4-star question, we have done this, and here this problem can be done. Only the difference is 15 is here. You transpose this 15, exactly this question will become like this, and you can do the problem. Two sides in this fashion are given, otherwise a ratio is given. Then cot A means the ratio adjacent by opposite is given. According to that, you can apply. Okay, now you can do this problem. Also, you can do this problem also, you can do this problem also, you can do this problem also. Then what is left out? Only the problem number 6 is left out. Let us take this type of problems in a different manner because it requires a different technique to solve. So in the next class, I need to bring some higher order thinking skills questions to you based upon the trigonometric ratio. So let us take some of the questions and solve them. But today in this class, in this module, to practice questions are in front of you. Take these, note down these questions, practice them, check out the answer, push your confidence level, and let's move forward. Proceed to next question. Thank you. Yes, welcome to my digital classroom. Here we are learning trigonometry. In the trigonometry, we capture firstly the knowledge which is required, the prerequisite knowledge which is required to understand the trigonometry. Then we started trigonometry, and in the trigonometry we have learned the first topic of trigonometry. It is trigonometric ratios. And after completing trigonometric ratios in the first level, we have taken the exercise 1 from NCERT textbook. Also the exercise, nearly 8 to 9 questions were there, and we in that were able to solve nearly all the questions, but 2 questions were left which requires different knowledge. So those type of questions and many special type of questions on trigonometric ratios are to be addressed in this class. So let us go to different types of questions now. Yes, the question is in front of you now. You got a question which is one of the example problem of NCERT, and these type of questions are there in our exercise also, and many questions are there in many books. And on this particular technique, you may be asked so many questions. So let us see what is given, how to solve, what technique should be used. Now the question is like this: in triangle OPQ, right angle at P, and OP is given, OQ minus PQ is given. Determine the value of sine Q and cos Q. Here directly one side is given, but he have not given us other side, but a relationship between other sides is given. So let us see how to solve the problem. Let us take one right angle triangle and start solving this problem. Solution for the problem number. It could be like this. Now triangle OPQ is talking about, so let us draw one triangle. I'm drawing a triangle for your sake now. Okay, triangle is in front of you. O P Q, right angle at P. So we got it, right angle at P. OP is 7, we got it 7. Given things will write here, given OP is equal to 7, OQ minus PQ is equal to 1. As OQ we don't know, PQ we don't know, there is two unknowns are there. Can we make these two unknowns and represent in the one unknown form? Because how many unknowns are there, that many the difficult technique you make it. That is OQ, if I represent, let PQ is as X, then OQ can be written as OQ is equal to 1 minus PQ by transposing, then OQ is equal to 1 minus X. So now you please see, we considered PQ as X and we got OQ as 1 plus X. Can we get a relationship between an equation of some kind where we can solve the value of and find the value of X? Can you tell me? Yes, can you what will be the technique? A right angle triangle out there is in front of you, and OP is 7, PQ is X, OQ is 1 plus X. So in this way, if we are having one unknown, and then we must have an equation. So where do we get equation? Yes, Pythagoras theorem itself gives us an equation. Let us apply Pythagoras theorem and solve this problem. Now let us take Pythagoras theorem and solve this problem. So we are applying Pythagoras theorem now in triangle OPQ. By Pythagoras theorem we will get, so please see, OQ square is hypotenuse OP and PQ. So you'll get by Pythagoras theorem OQ square is equal to OP square plus PQ square. Your OQ is 1 plus X. OP is 7. OP is 7 square plus PQ is X square. If you see, yes, PQ is X, OP is 7, OQ is 1 plus X. Now you can expand this with the help of your basic identities. A plus B whole square, 1 square plus 2AB plus X square is equal to 7 square. 49 plus X square. Can this X square and this X square get cancelled? Yes, you can cancel it because they are of same sign, but in LHS and RHS opposite directions. Means in one X square is in LHS, one X square is in RHS, so you can cancel them. Now what I want to do is I want to cancel it, and 2x is equal to 49 minus 1. X is equal to 48 by 2. I may get 24. I got X value as 24, 1. And then according to our supposition, PQ is X. So I got PQ value. And X value, I got it 24. I can write here 24. And one more here, if I substitute 24, then collectively OQ will become 25. Now I got all the values of the sides of a triangle OPQ. Now he wants us to find sine Q and cos Q. So we can initially note down that required to find was sine Q value and cos Q value. Let us go and do this finding. Sine Q is nothing but opposite side of Q divided by hypotenuse. Then you please go to the right angle triangle and see. Q is here, so with respect to Q we are talking about, then this will be opposite and this will be the adjacent side, and this is hypotenuse. According to the right angle triangle in front of you, sine Q will be 7 by 25, or otherwise name OP by OQ. OP by OQ, that is 7 by 25. Yes. Similarly, cos Q, you can find adjacent side of Q by HYB, hypotenuse, according to the definition. That is, adjacent side is here, hypotenuse here. So I can write PQ by OQ. So go PQ by OQ, and PQ is 24, OQ is 25, hence you got the answer. In this way, you can solve this type of little tricky questions, or also in this way you can solve easily. So okay, what was the question here? There was a right angle triangle where one side was given, but the other two sides relationship was given. Then we have done by using our Pythagoras theorem, and we have suppose one of the two sides as x, then we brought other side value in terms of x. Then when we write here in the substituted those values on the right angle triangle sides, then only one variable x was seen. Then we applied Pythagoras theorem, we got a quadratic equation, but luckily this x square got cancelled and it reduced to linear. Then we got x value readily easily. That x value, when we substitute in our supposition, then we got our values of the sides. Then we found all the trigonometric ratios. He asked us to find sine Q and cos Q. Then we found it. If he asked many other trigonometric ratios also, we could have done that also. Now one more question of this kind for your sake to practice will be given to you. Let us take that. So here is a question for you of the similar kind, and everything we have just seen in that format. The question is brought to you. You please take this question, and this was a question which was pending in the first exercise in the basic level. Please take this question and solve it. I request you, whenever the question is given, to practice. You practice and get an answer. And if you are getting any doubt, or you struck over somewhere else, you please take the photograph of your structure problem and post on my WhatsApp group. Then and that itself will be addressed. So now let us go to next type of questions, which are sorry, it is little bit different, and it requires a different technique to solve, and that question is now in front of you. Yes, the question is in front of you, where the question is telling us if angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. What he wants us to do in this problem, let us keenly observe. He's telling angle A and angle B are two acute angles. He have not mentioned that angle A and angle B are two angles of the same triangle. That is the number one thing we have to understand. And he told us that cos A ratio is equal to cos B. It means that there are two different triangles, where one you are having an angle A, another way somewhere another right angle triangle is there, and you are having angle B there. The cos of A in this triangle, for example, it is equal to cos of angle B in another triangle. Then we have to prove that angle A is equal to angle B. So let us take a pen, and according to the question, let us say this is our triangle A. Okay, B we are using here, so need not take a B here. A, D, E, B, C, D. Let us take A, B, no, A, C, D, and B, P, Q. Let's take these two triangles like this, ACD, BPQ, or you can change the vertices, but angle A should be in another triangle and B should be in another triangle. That's only makes us confused. No problem. Let us now the right angle triangles, two right angle triangles. A is here, B is here. According to the question, he told that cos of A is equal to cos A is equal to cos B. Means what he has given us. If he has given this ratio, he has given that the two ratios are equal. What are the two ratios? Cos A ratio is adjacent side of A by hypotenuse. So this is my adjacent side because we are talking about A, and this is my hypotenuse. Then cos A will be AC divided by AD, and according to this triangle, cos B will be BP, because this is adjacent, this is my hypotenuse. To look better, right angle is here, so it is BP divided by BQ. He has given these two ratios. Well, we need to prove these angles are equal. So in order to solve any problem of geometry, you need not take pen and start solving a problem like a algebra, but you need here a picture and the method by which you're going to solve. So you have to analyze the procedure, analyze the answer first, in which method shall we go, then only you can write something and start. Like algebra, if some brackets are there, you are opening and we'll see what happens. Let us see next. That thing will not happen in geometry type questions. So you have been given two sides ratio, and he's asking us to find that angles are equal. So technique shall come in front in our mind first. The technique will be let us prove these two triangles similar. And how can I prove that these two triangles similar is my concern. So these two triangles which we are having in front of us, two ratios are equal. These two ratios are equal as tells that the two triangles can be similar if their corresponding sides are in same ratio. So I got here two ratios same, two sides are in same ratio. I want all the sides must be in same ratio. My concern is to prove that the other missing side is also in the same ratio. Let us take this point and try to solve this. If I prove that these two triangles are similar, then these two triangles are similar means each and every corresponding angles are equal and corresponding sides will be in same ratio. So let us try to prove these two triangles are similar now. How to do is, let us AC by AD. You see AC by AD. I can write this itself. Let us consider this ratio is equal to, okay, because it makes a problem easy. So now I can write, moreover I can shift this to this side and also consider that to be K. AC by BP is equal to AD by BQ is also K, and I can write, if I transpose, I can equate this with this and I can write like this: AC is equal to KAD and BP is equal to KBQ. Maybe that will be useful to us in the next steps. Now what I want, these two ratios are corresponding ratios of the sides. What will be the third ratio? It should be CD divided by PQ. So now CD divided by PQ, I'm having this ratio should be equal to, so what shall be CD by Pythagoras theorem? I want to convert this CD in terms of given side. So CD can be written as CD by Pythagoras theorem, AD square minus AC square. Okay, so CD square can be written as AD square minus AC square. Similarly here, okay, BQ square will be equal to bq square minus bp square. Please note Pythagoras theorem. I am taking the Pythagoras theorem where I have transposed the hypotenuse to the other side. Okay, why I have done? Because I am having here and I want CD to be on left hand side and BP, BQ, PQ to be on left hand side. In that way Pythagoras theorem have been taken. So if I transpose the squares also, this square, then I get a CD under root. So those values I'm writing here now. CD whole under root, okay, AD square minus AC square, AD square minus AC square, and in the denominator can write under root BQ square under root BQ square minus BP square, BP square. Okay, now we shall use AD value can be written as, AC value can be written as KAD, BP can be written as KBQ. Let us do that one. AD square is minus KAD square, whole square it will become now, under root BQ square minus BP is KBQ again. So we are writing KBQ whole square. Now let us move to further simplification. So AD square minus K square, AD square divided by under root BQ square minus K square, BQ square. Can I take AD square and the BQ square in the numerator and denominator common? Yes. And after taking common AD square, I can remove it from the square root outside also. So it will become AD under root 1 minus K square divided by BQ in the similar manner. BQ under root 1 minus K square. This you can cancel. What you got now? Your left hand side is CD by PQ. It is continuation. CD by PQ, and you are left with AD by BQ. If you see what is AD by BQ, AD by BQ is your K. AD by BQ is K. So you can write here is equal to K. Hence we can write triangle we can write like this. Hence eraser, erasing pen. What was the two sides were taken here now was AC by A. What was that? AC by BP. AC, hence AC by BP is equal to AD by BQ is equal to CD by PQ. That implies triangle. What are the triangles? A, C, D, similar to triangle B, P, Q by triple S similarity criterion. That implies by CPST. What is CPST? Corresponding parts of similar triangle. What do you mean by this? That is, if two triangles are similar, their corresponding angles are equal. In order to tell that, we are writing a short form, that is CPST. Corresponding angles are equal. It means angle A should be equal to angle B. Hence, proved. Hence, we proved that in this similar manner. So you please see complete solution in front of you in the smaller font. So I put it for you now. You see, please, if any step is missing, you can stop the video and see everything. I'm taking from top to the bottom. So here we have used Pythagoras theorem. We must mention here by Pythagoras theorem. You need to write full forms always. By Pythagoras theorem. We got it. Yes, there is a practice question to you in front of you is coming right now. Let us increase the font and give you a question now. I got a question for you now. The question is here. If angle B and angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. You take this question and in similar manner you please solve it. Now I would like to tell you there is no confusion here because he have given an angle B and angle Q which are very far, so easily you can understand we are going to take two different right angle triangles. But in the question which we have solved, he mentioned as angle A and angle B, which are two consecutive letters. Normally we are going to use them in a one right angle triangle ABC, but we never take angle A in one triangle and angle B in another triangle. But that was the scenario and the case where he made us confused. So now take this question for your practice session. Pause this video if you are with pen and paper and take this, solve it right now. Let us go to another model. Okay, now I have given you a worksheet, number one worksheet for the chapter trigonometry, which completely is made to solve with the help of trigonometric ratios knowledge. So number one question is in front of you, number two, number three, number four, number five question. Every question is easy, and all the models which we have seen it, but you have to put your pen on paper in order to practice. Now in question number 5, just I want to give you a hint, that is you are having a cos and sine collective related time equation. You please bring all the causes to the left hand side and all the sine to the right hand side, simplify it, then convert it to tan and use the trigonometric ratio value, that is sine by cos is tan. What is sine by cos? Tan. Sine divided by cos is equal to tan, and how we get that is from trigonometric ratios itself, because sine is opposite by hypotenuse, cos is adjacent by hypotenuse. If you divide these ratios, hypotenuse and hypotenuse get cancelled and we are left out with opposite by adjacent, and that is the ratio for the tan. That is why we also use sometimes sine theta divided by cos theta as tan theta. So you use this technique and try to solve this. Okay, so worksheet number 1 is on your screen. You have to note down these questions, put pen on the paper and practice, and if any problem, please use WhatsApp and ask me the doubt. There and there itself we can clarify. Here we end the first topic of our trigonometry. It is trigonometric ratios. Here comes the next module where we are going to understand trigonometric standard values and complementary trigonometric angles. Let's go. After completion of our trigonometric ratios topic, let us go to understand trigonometric ratios for some standard angles. And what are the standard angles? Let us see. Standard angles normally are considered in our basics to 10th class level. They are 0, 30 degree, 45, 60 and 90. 0, 30, 45, 60 and 90, they are standard angles. So trigonometric ratios, when we are applying on the triangle where one of the angle, almost we are considering right angle triangles, and in the right angle triangle, if one of the angle is any of the standard angles, then how the trigonometric ratios values we will get. The 0, 30, 45, 60 and 90 we are discussing, and whatever the results we are getting here, we'll make a tabulation and we have to learn and those results. And whenever in the coming problems, we can directly use those values and we have to use them. So I'll in this class only will learn this concept clearly and enjoyingly. Okay. Yes, now let us take one of the example problem. What is going to happen? See, yes, let us now take a trigonometric, find trigonometric ratio values for angle 30 and 60. In order to find the values for 30 and 60 degree, we have to take a triangle, and which triangle it is? Equilateral triangle of side 2a. Let us side 2a. Let us take a right angle triangle, sorry, equilateral triangle in front of you. Now I'm going to insert a equilateral triangle in front of you now. Okay, the equilateral triangle is in front of you now. Okay, you got it in equilateral triangle. Let us name these sides of equilateral triangle now. It is A, B and C, and I want a altitude also. Let us take a altitude. Let us take a altitude perpendicular. Yeah, it's got a perpendicular. Now can you tell me what will be the angles of the equilateral triangle? What will be? Yes, can you tell me what will be? This is the equilateral triangle where the angles will be 60, and this is also 60. Let us name here D. Actually this complete angle will be 60, but this altitude divide the 60 to two equal halves. In a equilateral triangle it happens. So it is 30, this is also 30. This is altitude, median and angle bisector, everything in the equilateral triangle the same one. Okay, now we got a diagram in front of you, and we consider let us okay, take equilateral triangle. Okay, let us I'll just take it. Okay, now construction. What it is? Construction. In order to do the problem, we have to construct a equilateral triangle of side, how much? 2a. Let us take side 2a. This is 2a side. This complete side is of 2a, and actually the altitude, median, angle bisector, everything are the same in equilateral triangle. That is why 2a divided into two parts, so it is a and a. This is 2a. Okay, and altitude is drawn, everything. Now in order to find the D ratios for 30 and 60 degree, we want a right angle triangle. So we got a right angle triangle ADB. In a right angle triangle ADB, whether we know each and every side, AB we know, BD we know, but AD we don't know, so AD we have to find in triangle ADB. Now in triangle ADB, by Pythagoras theorem, what is going to happen now? Directly AD square is equal to AB square minus BD square. Okay, we got it. Because whenever Pythagoras theorem we are using, if we are taking LHS as hypotenuse, then sum of the squares of other two sides. If we are taking any one perpendicular side on LHS, then difference of squares of hypotenuse and another side. So in this way we got it. Now we are substituting the values which we are having in front of us, that is 2a whole square minus BD is my a square. If I take 2a whole square, it could become 4a square minus a square. If I simplify it, like 3a square, ad square is continuing from the top, and ad is equal to under root 3a square, and which is equal to root 3a. Okay, let us push this triangle downside. Okay, so we got AD value as root 3a. Let us substitute root 3a in place of AD. So AD I got how much? Root 3a. So you got a root 3a. Let us keep this triangle here itself and find all of the trigonometric values for sine 30 degree now, for angle 30 degree. What is sine 30 degree? I write here now, sine 30 degree. What should be a cos 30 degree? What shall be a tan 30 degree? What shall be a cosecant 30 degree? What shall be secant 30 degree? What shall be cot 30 degree? Go to your diagram. 30 degree is here, and sine, if we are talking about, sine is opposite by hypotenuse. With respect to this 30 degree, this side is my opposite side, this side is my hypotenuse. So opposite by hypotenuse, BD by AB, that is small a by 2a. Come on, it is going to be BD by AB, and that is small a by 2a. If I cancel, I get a 1 by 2. Wow, sine 30 value is 1 by 2. Similarly, if I take cos 30, according to the diagram, cos 30 and cos ratio, it is adjacent by hypotenuse. So adjacent is my AD here, because 30 is here, adjacent is side. This one in triangle ABD we are talking about. We should not go AC and CD, we don't see that. Adjacent is AD, hypotenuse is AB, so adjacent by hypotenuse, it should be root 3a by 2a. Come on, root 3a by 2a. If I cancel, I get a root 3 by 2 answer. Similarly, you can find the other trigonometric ratio values. Come on, in this way you get all the trigonometric ratio values for 30 degree. And can you now for 60 degree, can you find now sine 60 degree, cos 60 degree, tan 60 degree, and cosecant 60 degree, secant 60 degree, and cot 60 degree? Yes, one sine 60 I'll do for your sake. Let us go to the triangle ADB. 60 is here. With respect to 60, we are talking about sine 60. Then it should be a, what is sine? Sine is a ratio which is opposite by hypotenuse. So sine 60 should be opposite side of 60 degree by hypotenuse. So 60 is in front of you. This is my 60. This is your high opposite, and this is your hypotenuse. So 60 opposite by hypotenuse, AD by AB. So sine 60 from the diagram, it should be AD by AB, and it should be AD is a root 3a, AB is your 2a, a get cancel, root 3 by 2. Wow, in this way you get a value sine 60 root 3 by 2 value. These are the standard values which we have to gather and remember. This will make the tabulation of these values. Okay, so let us go to, you please find this other from the diagram itself. Cos 60 degree, tan 60 degree, cosecant 60, secant 60, cot 60 value. Let us go and find the trigonometric ratio values for the angle 45. Yes, now let's go to. Now let us find the trigonometric ratio values for the angle 45. I have to consider a figure to bring the values of T ratio, that is trigonometric ratios for the angle 45. I have to take a figure, so please think which figure will make sense. Okay, let us think. Oh, come on, 45. Yes, a right angle triangle where one of the angle is 45, and luckily if in a right angle triangle one angle is 45, the other is also 45. It means we have to take a right angle isosceles triangle. Let us go and take one right angle triangle, which is right angle isosceles triangle. So you can note down here. Okay, we have taken. This is a construction. What is my construction? It is construction a right angled isosceles triangle of side A. Consideration is this one. Let us name this triangle as PQR, where right angle isosceles triangle compulsorily will have 45 degrees as the two base angles and 190 degree. And we have considered the sides also to be they will be equal. Isosceles triangle, two base sides are equal, two sides are equal, and we consider let it be of a centimeter. Side A, come on. Now in a right angle triangle I know two sides. Whether I know PR value? No. How can I find the PR value? Yes, Pythagoras theorem. I think that clicked on your mind, Pythagoras theorem. So you're right. In triangle PQR, PR square is equal to PQ square plus QR square. Okay, so PR square is equal to A square plus A square. Can you tell me A square plus A square is equal to 2A square? And PR value, you got it, PR square value. Now PR will be under root 2A square, should be root 2A. How much? Root 2A. Let us substitute here, root 2A. In a right angle triangle, all the three sides have been known. Now I can get all the trigonometric ratios. Now I want my sine 45. Sine 45 is opposite side of 45 degrees by what? Hypotenuse. So let us go to right angle 45, whether you can use this 45 or this 45. Nothing is going to happen. Now opposite by hypotenuse. Opposite is A, hypotenuse root 2A. It's going to become A by root 2A. If you cancel A, 1 by root 2. Yes, in the similar fashion, you please try to get the cos 45 value. Then again you'll get something like 1 by root 2 only. And tan 45, cot 45, cosecant 45 and secant 45, the values are waiting to be found by you to itself. Now I want to find the trigonometric standard values for 0 and 90 degree. How we can get those values? In order to understand that values, you please see the simulation which I want to make with the help of a right angle triangle, which I am going to take from the insert of word. Now let us take a right angle triangle in front of you. You please consider this figure, and I'm sorry to, okay, now see here I got a right angle triangle. Now if I okay, let us take once again, you please consider what I want you to understand. You please see here now. Okay, as I am moving, making my altitude constant and moving the base, as the base side is decreasing, my one of the angle is increasing and increasing and increasing and increasing. The base is vanishing at one instant exactly, and my angle increased and became about 90 degrees. You see here now, for example, the angle is how much? 15, 30, 45, 30, 40, 60, 70, 80 and 90, and exactly that will overlap, base vanishes. So in that case, base gone. What the value of base you will take there? 0. Similarly, if you consider like this now, please see this. Now I have a right angle triangle in front of you. I am moving it here. I want the angle to become 0 now. At that case, in the previous case, what the angle became? Angle increased and became 90 degree. Now you see here. Now I want to, you see once again, okay, now see here the angle is decreasing, 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 decreasing. So what is happening when angle is decreasing? The altitude side, the opposite side is vanishing. The two consideration we have to consider, and let us bring the values for sine zeros now. Now please see. Now please consider trigonometric ratios for angle 0. So what is going to happen if we are doing this activity? We are keeping our side AB the constant, and we want to reduce this angle. This angle is reduced, it became like this. This angle is reduced further, it became like this, because we want to reach 0. When we are decreasing this angle completely, what is going to happen? This BC, the opposite side, is going to be vanished, and it is no more BC. BC became 0, and AC and AB overlapped. In that case, if we want our trigonometric ratios to be found, how can we found it? So sine 0 will be opposite side by hypotenuse. Opposite side vanished, and we don't have opposite side, so that is 0, and that is why the sine 0 value is 0. In this similar fashion, you can find other trigonometric ratios also. If we see the trigonometric ratios for the 90 degree, you please consider this figure way. We have keeping opposite side BC the constant, and want to increase this angle further and further and further. We increase the angle, it became like this. We increase further, it became like this. It increased, and if we increase further, it became like this, and still we want to exactly become 90. Then it became like this, and we don't have here adjacent side, now be gone there. Here in this case opposite side gone, here adjacent side gone. Therefore when the adjacent side gone, according to the trigonometric ratios, you can find wherever adjacent is there, you can substitute 0 degree 0 value there, and you can get trigonometric ratios. Let us make all the trigonometric ratio values which we got from the geometrical simulation part. Let us tabulate it and remember. Okay, let's go. So in this way we got sine 0 value as 0. How? Because if you see the above triangles, as we reduce the opposite side to 0, completely 0, then only our angle became 0. So angle became 0, opposite side vanished. So sine 0 means there is no opposite side, that is why 0 divided by hypotenuse, so answer is 0. In similar manner, if you take cos 0 value, the adjacent by hypotenuse, here adjacent is also AB, and hypotenuse came and overlapped exactly like this on AB, so it is also AB. So therefore AB by AB cancel, you see exactly you will get as 1. So AB by AB adjacent by hypotenuse, the both became AB, and answer is 1. In this way, if we are calculating sine 0 and cos 0, then you can calculate for cosecant, secant, and tan and cot also. Trigonometric ratios for angle 90 degree will be done in this manner. As we move towards B in this diagram, I want to increase the angle, so further increase BC remaining constant. As we move towards the altitude side, making the angle increasing and increasing. At last, what happens? Adjacent side vanishes, and exactly angle becomes 90 degree. When angle becomes 90 degree, now we have to calculate trigonometric ratios for this particular angle 90 degree. What we can consider here, adjacent side of 90 degree is 0. The by default 90 degree we don't consider. As we proceed, and we get 90. So adjacent is 0, opposite is opposite, hypotenuse and opposite overlapped each other. So if we want now sine 90 value, sine 90, exactly what is going to happen? Opposite by hypotenuse, and opposite is also BC hypotenuse is also BC because they both overlapped each other. So BC by BC answer is going to be 1. Similar fashion, if you want cos 90 value, adjacent by hypotenuse, adjacent is vanished. We got adjacent as 0. Now answer is 0. In this way, as we found for sine 0, sine 90 and cos 0, cos 90, you should find for other trigonometric ratios. Now let us go to make the tabulation of trigonometric ratios. Now, so here I have a table. Let us complete the table with trigonometric ratios and standard angle. Let us keep 0 here and 0 here, 30 degree and 45, 60, 90. Let us write here T ratios. Means it is sine, cos, tan, cosecant, secant and cot. Everywhere, if I am talking about sine 0, so sine 0 here. So sine 0 value and sine 30 value, sine 45 value, sine 60 value, sine 90 value, whatever the standard values which we have seen just above. Some values I bought it and I told some other values to be done by you. So whatever the values you got, you please note down in the table. And to remember, how to remember is a very simple technique. You please remember the sine row. So we got a sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So you get a 0, half, 1 over root 2, root 3 over 2 and 1. You can tell like this also 0, half, 1 by root 2, root 3 by 2 and 1. One row like a phone number you should remember. Then in order to get the cos values from these values only is very easy. Writing from the 90 degree in a reverse order, you just get the values of cos. I am telling one word here because after doing this we will be doing some of the problems on these trigonometric ratio standard angles. Then we are going to complementary angles. So what do you mean by complementary angles? In that case I'll explain you there. But writing from the right side is also called as complementary. So sine and cos, they both are complementary to each other. If I write completely in a reverse order, it means that I am complementing it. So cos 1, root 3 by 2. It is 1 by root 2, 1 by 2 and 0 here. If you want the tan value, you have to divide sine and cos. Sine divided by cos is tan value. So if you divide 0 by 1 is 0, 1 by 2 by root 3 by 2, these two denominators will get cancelled, 1 over root 3 will be left out. The same if you divide, you'll get exactly 1. 2 the denominators will be cancelling, exactly you'll get root 3. 1 divided by 0 is infinity. We don't have any, not defined. 1 by 0 in maths is called as not defined. If you want cosecant value, the reciprocal of sine makes you exactly cosecant. So 0 can be written as 0 by 1 and reciprocal of 0 by 1 is 1 by 0 and 1 by 0 is not defined, we have seen. Similarly 1 by 2, 2, root 2, 2 over root 3, 1 by 1 is 1 again. Secant can be reciprocal to cos, you get the secant, or otherwise complementing the cosecant to get secant. What do you mean by complement? Writing from the right side you will get. So write 1, 2 over root 3, root 2, 2, infinite. Cot you can complement to tan or reciprocal to tan. Complement writing from right side, otherwise reciprocal. This is only the scenario you are reciprocaling, also the same answer you will get. If you are writing from the right side, also the same answer you will get. It's a amazing thing here. Infinity, root 3, 1, 1 by root 3 and 0. So in this way we have completed our trigonometric ratio standard angle table. You please make this standard table more and more times. let us make it 6 to 7 times, then automatically you will be able to make it also, and you remember the standard angles also. So now what we have to do, we have to take the problems on these particular standard angles. Let's go to take problems now. Let us take some of the problems now. Some problems here are evaluate the following, and some problems here are choose the correct options and justify your answer. Some problems here are if tan of a plus b is equal to root 3, tan of a minus b is equal to 1 over root 3, then we have to find the two angles A and B. And some questions are state whether the following are true or false, justify your answer. And some questions here are again, so let us see each and every type. In the evaluate the following, one question for your kind of information in consideration, I'm going to solve it, but the rest of the problems you are going to do. So which problem shall I solve it? So I am going to solve the problem number 5. Take it, problem number 5 for you. 5 cos square 60 plus 4 secant square 30 minus tan square 45 divided by sin square 30 plus cos square 30. Wow. How to do this problem? Directly you see the angles are standard. So take the standard trigonometric ratio values from the standard table which we made just. So consider the cos 60 value should be how much? 1 by 2. Take it. Secant 30 value is equal to 2 by root 3 from the tables. And tan 45 value consider take from the table 1. Sin 30 value take from the table as 1 by 2. Cos 30 value take from the table as root 3 by 2. These values are to be taken from the table and substitute in the simple evaluate following. So we are evaluating now 5 times cos 60. Cos 60 value is how much? 1 by 2 square plus 4 secant 30 value. Secant 30 value is how much? 2 by root 3. 2 by root 3. Square is there, you can square. If cube is there, cube. Otherwise, no power, don't write any power. Tan 45 is 1 and whole square divided by sin square 30. Sin square 30, how much is sin 30? 1 by 2. And sin square 30, 1 by 2 square. Plus cos 30. Cos 30 value, we have written here. Root 3 by 2. So it should be root 3 by 2 whole square. Come on, let us solve this particular step now. 5 1 by 4 as square. 1 square is 1, 2 square is 4 plus 4 times 2 square is 4, root 3 square is only 3 minus 1 divided by 1 by 4 plus root 3 square is 3, 2 square is okay, we got it. Next we got it 5 by 4 plus 16 by 3 minus 1 divided by, as the denominators are 4 and 4, we can simplify. 1 plus 3 is 4 by 4 and we cancel it, you don't get any denominator now. So now to simplify this numerator, let's take a LCM of these 4 and 3, it is becoming exactly 12. I have to multiply 5 times 3 here, and 16 should be multiplied by 4 and 1 should be multiplied by 12 in order to make a equivalent fraction and simplification part. 15 plus 16 times 4 is 64 minus 12 by 12. How much will be the answer? 64 plus 15 is going to become 79, and you are reducing by 12. 67 by 12 will be the answer. In this way you have to simplify. That is the thing here in the problem which we have solved just now. We got a fraction of a fraction type. We in pre-trigonometry already have seen. If squares are not there, then we would have got here irrational fraction of a fraction type, and that also we have seen in the previous pre-trigonometry concept. So here the question number 4, I think you may get fraction over fraction type with irrational numbers because there are no squares. So you should do the problem number 4 very keenly because it's a irrational fraction of fraction type, and I don't want to solve this one. You need to solve this one because already we have seen the simplification part in trigonometry. Now we are doing what we have to do this problem. Just take the values sin 30, tan 45, cosecant 60 and these values from the standard table, put here exactly. You will reach here without any squares. You simplify, come on, or you can do the problem 1 2 3 everything. Let's move to choose the correct answer type questions now. How to solve the questions. Choose the correct option, justify your answer. So let us take one of the questions for you. Say the question number 1, 2 tan 30 by 1 plus tan square 30. If we are having a type of question in this manner, and the question is telling us to choose the correct one among the 4. Number 1 question is, let us simplify first of all 2 tan 30 by 1 plus tan square 30. What you may get, we'll see. 2 tan 30 1 by root 3 divided by 1 plus tan square 30 1 by root 3 whole square. Any problem? No problem. Then 2 over root 3 divided by, if you simplify this, you'll get 1 plus 1 by 3. Then further simplification gives you 2 over root 3. Here cross multiplication 3 plus 1 by 3. You will get 2 over root 3 times 3 by 4. If you cancel 2 times like this, you will get, I'm sorry, this is not 3, this is 2. Take a eraser, erase it, write once again 2. What is left now? 3 by 2 root 3. We don't have any standard value 3 by 2 root 3. Can we simplify this? I can write 3 as root 3 times root 3. Then I can cancel 1 root 3. I'll get root 3 by 2. So which of the option gives you root 3 by 2? The option sin 30 is 1 by 2, tan 60 is only root 3, cos 60 is 1 by 2, sin 60 is your root 3 by 2. So this will be your correct answer. Okay, as sin 60 you can write here, and we know that sin 60 is equal to root 3, hence the number 1 answer. This A will be the correct one. In similar fashion, you can try number 2, 3 and 4. Come on, you please try these answers. Let's move further. Here in the third question, sin 2a is equal to 2 sin a. So you see there is no simplification part, so put this 0 in the place of a and see whether LHS is equal to RHS or not. Okay, if it is not, then substitute 30, then 45, then 60 and see where the equation is correct, becoming LHS is equal to RHS. Let's move further to see the problems of a kind. This is very nice question, important type of questions. Yep. Now let's see a very important question. If tan of a plus b is equal to root 3 and tan of a minus b is equal to 1 over root 3, then we have to find a and b value. Many questions of this kind can be framed, and you will get some of the questions in practice type. Now if you want to solve this type of problems, how to solve these type of questions, let us see. Now tan of a plus b, now you see given tan of a plus b is equal to root 3, and from the tables if your tan is there, then you check whether for what standard angle this root 3 is coming in the tan. So tan 60 gives root 3, yes or no? So let us take, now we know that We know that tan 60 is equal to root 3. That implies I can write tan of a plus b is equal to tan 60, or I can write a plus b should be 60 degree. In the similar manner, similarly, I can write now for the right one more equation. Tan of a minus b is 1 by root 3. Similarly, tan of a minus b is equal to 1 over root 3. I can write tan of a minus b is equal to 1 by root 3. From the standard angles, it is tan 30 degrees. So I can write a minus b is 30 degree. I got equation number 1, a plus b 60. I got equation number 2, 1 more t. So two variables are there and two equations are there, and we have already discussed about pair of linear equation in two variables. So these two equations are to be solved with the help of pair of linear equation in two variables, and moreover, these equations are ready-madely made for elimination. So let us solve by elimination method to solve. So a plus b is equal to 60, a minus b equals to 30. Then you can just cancel it. I am sorry. Just cancellation, because already the signs are plus and minus. We no need to worry. And a is 90 divided by 2, exactly 45. In equation number 1, if I substitute, I'll get 45 minus b equals 30. 45 minus 30 is equal to b, 15 equals to b. So I got the values. A is equal to 45, b is equal to 15. Hence I found this. Similar type of questions are ready. They are coming today's worksheet. Come on, let us proceed with another type of question to you. Here are some of the state whether the following are true or false type questions. So question number 1 is here telling us, tell me whether it is true or false sine of a plus b is equal to sine a plus sine b. Solution for this, whether we have to put true or false. Let us see now. Number 1, sine of a plus b is equal to sine a plus sine b he is talking about. Let a is equal to 30 and b is equal to 60 degree, and check whether LHS and RHS are getting correct or wrong. So we substitute both values, okay, and see sine 30 plus 60 is equal to sine 30 plus sine 60 degree. Sine 30 plus 60 is becoming sine 90 and its value is 1. Sine 30 value is 1 by 2, sine 60 value is root 3 by 2. If I am simplifying, I'll get this one, and it tells that it is not equal. Hence, we conclude, okay, that we conclude, let us erase this conclude, is not looking good. I'll write it neatly. Conclude that sine of a plus b is not equal to sine a plus sine b. Hence we conclude sine of a plus b is not equal, means the statement is false. Can you see here the another one? The value of sine theta increases as theta increases. Yes, this statement is correct. As we have seen in the table, it sine values starting from 0, then it becomes 1 by 2, then 1 by root 2, then root 3 by 2, then 1. If you see, the values are increasing, then the value is increasing, hence we can tell it is correct. The value of cos theta increases as theta increases. This is a false statement because it is just opposite to sine. As sine increases, cos decreases. Sin theta is equal to cos theta for all the values of theta is false statement, because sin theta is equal to cos theta we have seen in the standard table only at 45 degree only, because sin 45 is 1 by root 2, cos 45 is 1 by root 2. We never get the trigonometric standard angles equal. Only at 45 we get equal. Chord A is not defined for A is equal to 0. Yes, chord A is not defined when angle is 0. This is correct statement. As we have seen, tan 90 is infinity, not defined, and chord 0 is also not defined. So in this way we got the true or false type solutions. Now let us proceed to see the different types of questions. Now the problem number 8 already you can do. We have seen these type of questions in tan, so plenty of questions can come of this kind. If you are having a sine, so check it out, 1 by 2 value for what angle in sine it is coming. So there we have seen for tan, here for sine you have to do, and here cos is there, so 1 by 2 value in the standard angle for trigonometric ratio for cos when it is coming, for what angle you please take it, you'll get answers. So sixth problem, this kind of question, question number 6 here, which is written in triangle ABC, right angle at B, AB is 5, AC is 30 degree, determine the lengths of the side ABC and AC are the trigonometric ratios. We don't need to find, but here he is asking us to find other sides. Let us do this problem. Okay, for your sake I have taken a triangle in front of you also. Let us proceed to solve. He is telling triangle ABC, so let us take a triangle ABC, and AB is 5, so let us take AB is 5, and ACB is 30, so let us take it is 30, and determine the length of the side BC and AC. So BC is how much we don't know, AC is how much we don't know. How to do this problem now? Yep, one angle is given, one side is given, all the sides we can bring with this information. Now let us find BC value. In first step, let us find BC. Let us choose BC. AC, next step. So if you want BC value, take what side is given and what is the name of the side which we want to find. Given side is AB and is called as opposite side. And here, if you see, it is opposite. 30 degrees here, 30 degrees here, and this is opposite. And I want to find BC, and BC is adjacent side. So opposite is given, adjacent side I want to find, opposite and adjacent, this collectively, which trigonometric ratio it can be? Come. So opposite, adjacent. If you see opposite, adjacent, in this way, opposite divided by adjacent is tan. So in triangle ABC, tan 30 degree is AB divided by BC, and tan 30 degree value from the standard table is 1 by root 3. AB value from the diagram is 5, and BC we don't know. So now you got a statement where only one variable, equation where only one variable is there. You can solve it to get the answer. 5 root 3. Here's just cross arrangement we have done to get the answer. BC value got. Similarly, now I want AC value. So what is the technique? You should never forget the technique. What is the technique? Please, can you tell me? Yeah. AC. What is AC? AC is from the test figure. AC is hypotenuse. Okay. I want to find. I don't know AC. What is given? AB. What is side AB name? Opposite. Okay. I want to find hypotenuse, and I have opposite side, opposite, hypotenuse, opposite. Which trigonometric ratio it becomes? Opposite hypotenuse. Wow. Oh, yes, you told correct. What it is? Opposite hypotenuse is sine 30 degree. Okay, let's take sine 30 and do the problem now. Okay, sine 30 is opposite by hypotenuse. So opposite is how much? AB 5, AC we don't know, so 5 by AC. I'll write 5 by AC. Sine 30 value from the standard table is 1 by 2 5 by AC. If you again do this fashion of arrangement, you will get AC is equal to 5 times 2 10. In this way, the unknown sides can be found. Means what? If in a right angle triangle, if the statement is very important, if in a right angle triangle any one angle is given other than 90 degree, 90 degree is a right angle triangle, 90 degree is there, other than 90 degree one more angle is given and one more any side is given, all the trigonometric sides, all the sides information we can get, all different angles also we can get. Understood? So let us go to problem number 7 type. So different methods we are seeing. This is another method of type of question. Each method one problem, rest your problem, means you need to solve them. So in triangle PQ, right angle at Q, see figure 8.20, but we don't need to see the figure. What we need to do then? We have to draw that figure. Okay, let us. So in this question, let us read the question. In a triangle PQR, so I have to consider triangle PQR also in front of you. The triangle is there, and he told us also right angle at Q, so it should be PQR, and PQ is 3, so I should write here 3. PR is 6, so PR is 6, I should write 6. Determine other. So in this question he have not given us the angle, but he has given information of two sides. So again the trigonometry comes into play, and it tells that if any two sides ratios are given, then I can find all the angles also, and I can find other trigonometric other missing side also. Okay, let us try this question now. So let us find R. So where is my R? R is here. With respect to R, I want to find R. I want to find R. With respect to R, what are the given sides? Given sides are opposite side. See here, it is a opposite side. Okay, and this side is hypotenuse. So I will write opposite here and hypotenuse here. Now let's again think. Which trigonometric ratios can be made with the help of these given sides? So opposite, hypotenuse, opposite, hypotenuse, opposite, hypotenuse. What? Opposite, hypotenuse. Wow, I think you got it right ratio. So in triangle PQR, sine R is opposite by hypotenuse. Okay, so it should be PQ by PR. PQ is 3, PR is 6. If you reduce to the smallest format, so it is becoming exactly 1 by 2 sine R. So go to the standard tables and check and tell me when sine R is 1 by 2 from the standard table. Sine 30 degrees is going to be 1 by 2, so we know that sine 30 degrees is equal to 1 by 2 implies sine R should be sine 30. It means R must be 30 degree. Yeah. So in this way, if I get one of the angle R as 30 degree, you can directly use complementary angle value, that is it will be 60 degree, because in a right angle triangle, if one other than 90 degree, if one angle is 30, automatically the sum of other two angles should be what? 90. So 60 plus 30. If one is 15, other should become 75. If one is 45, other is also 45, because the two angles sum should be 90 degree, because angle sum property tells that if I add all the angles, it should be 180. Yes, so in this way, one of the problem we have seen, and this is the actual practice question. You please take this question and do it. Now I'm going to give you worksheet number 2. So worksheet number 2 is coming in front of you. Be ready. Okay, a small worksheet is brought to you. Please take this worksheet. Problem number 1 to be solved with the help of standard table. Problem number 2 with the help of standard table. Problem number 3 by substituting a useful value from the standard table and making the Asian's pair of linear equation, two variables, and the problem number 4 and 5 just we have seen. Here the problem number 5 is having a, b and c, three variables, and will get a two equations from here, third equations to be taken from your common sense, because he told right here angles a, b, c are the angles of the triangle, then a plus b plus c should be equal to 180. Then three equations, you please use these three equations and try to eliminate c first, then the two equations you will get in a and b, then solve. Come on, the simplification part will be a little easy when you put your pen on paper and practice. That will be different. Come on, do this. And any problem, you please visit to our WhatsApp group. Thank you. Let us copy this. I am scrolling. Wherever you are, you please stop and copy these questions. Thank you very much. Let's move to complementary angles in the next class.